In this video, we're going to talk about differentiation and its applications, mainly the application part. We'll be doing some questions that has to do with distances, maximizing and minimizing distances. So let's take a look at the very first question we have here today from HCI 2013 prelims. There are two particles, A and B, A here, B here. Particle A is at -13, 0, and particle B is at 0, -9. Okay, with respect to origin O, A moves towards O at a constant speed of u centimeter per second. So it's moving this way, horizontally. No diagonal movements, no vertical movements, just horizontal movement at a speed of u centimeter per second. And B moves towards O at a constant speed of 4/3 u cm per second. So it's traveling up and it's slightly faster than u. Show that after a time of t seconds, the distance between A and B is given by this horrible looking expression here. Well, it's 2 marks. You probably don't have to use differentiation yet. Looking at this distance, you should be thinking, I should be using some good old distance formula here, especially with this square root. It should be a clear indicator. So distance between A and B, just join them up, and you will sort of form a right angle triangle here. And our job is just to find the hypotenuse. And to do that, we will first of all need to find this length and this length. At time t, B will have traveled a certain amount, right? And we got to find out where is B after t seconds. So location of B after t seconds would be traveling up by 4/3 u every second. So the correct answer is distance traveled by it is just 4/3 ut, right? It will be 0, -9 plus 4/3 ut. So you will end up here after t seconds. This is where B would be. And then what about A? Location of A after t seconds would be you travel ut amount to the right. So it's -13 plus ut 0. All we have to do now, since we know where is B after t seconds and where is A after t seconds, all we need to do is use the distance formula. The distance between them, so for example, A might be here after t seconds, B might be here after t seconds. What is their distance? The distance would be just the hypotenuse, right? Equals to square root of -9 plus 4/3 ut whole thing square plus -13 plus ut whole thing square. Let's simplify this. 81 plus 16 over 9 u square t square minus 9 times 4 over 3 will give you 12. 12 times 2 will give you 24 ut. Let me extend the square root. Plus 13 squared is 169 minus 26 ut plus u square t square. Let's clean this up even more. 81 plus 169 gives us 250. 16 over 9 u square t square plus 1 u square t square gives us 25 over 9 u square t square. And finally, -24 ut minus 26 gives us -50 ut, which is exactly what they have here. So we are done with part 1. Part 2, find the coordinates of A and B at the instant where the two particles are closest. So we are done with the first part. This is just the distance, right? The instant when the two particles are closest just means that the distance is a minimum, right? Distance is a minimum. And to find the minimum, all we have to do is to differentiate this function here with respect to time, because we want to find the instant where the distance is a minimum. Simple. Let's just differentiate this. It might look difficult at first, but if you were to square both sides before differentiating, you will get this. D squared equals to 25 over 9 u square t square minus 50 ut plus 250. This is good because you're getting rid of the square root If you were to have this thing, you have to do that chain rule, right? Power bring down, power minus 1, and then you have this very nasty negative half power. To eliminate that issue, all you have to do is square both sides and then differentiate implicitly. What I mean is this: you will get 2d dd dt equals to, and then differentiate this side with respect to t as per normal. So you get 25 over 9 u square. This is just the constant that is attached to the variable, right? T squared. So power bring down, so this becomes 50 instead. T minus 50 u. And we're done. And then distance is a minimum, means dd dt equals to 0. Find t. This would be 0. The d is gone. The 2d is gone because this is 0. Equals to 50 over 9 u square t minus 50 u. Bring this over. You get 50u equals to 50 over 9 u square t. Simplify this. Divide both sides by u. 50. T would be 9 over u. So this is our golden ticket to this question. This is the time where the two particles are closest. This is the time where the distance is a minimum. So all you have to do now is, using this timing, after 9 over u seconds, where is A? A would be at negative 13 plus ut, right? And this t, how many seconds later? 9 over u seconds later, comma 0. Where would this be? A would be at negative 13 plus 9, which is negative 4, 0. What about B? B was at 0, negative 9, right? 9 over u seconds later, where would he be? He would have traveled 4 over 3 u and 9 over u. Cancel, 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 cancel. Negative 9 plus 12 gives you 0, 3. And with that, we are done with this question. So the second question of this video, JJC 2012 prelims. An offshore oil well is located in the ocean at W. So there is actually an oil well here. There's an oil well here. So your job is to pour this oil onto the land. You probably have a refinery here where you process the oil, which is 8 km away from point A on the land as shown on the figure above. Oil is to be piped to point B, which is 12 km away from A, using the straight pipe laid underwater from W to some point at P between A and B, and then onto B via another straight pipe laid on land. Okay, so your job is to get from W, get the oil from W to B, right? So there are many ways to do it. You can pipe it a straight pipe like this. Draw a straight pipe. This means that the entire pipe is in the ocean. Now the problem with this is, because laying a pipe underwater is actually more expensive than laying on land. So you have to find the perfect combination of how much pipe to lay underwater and how much pipe to lay on land. Well, if they cost the same, if laying a pipe underwater costs the same as laying on land, then it's rather easy, right? Just lay it straight. Get it there. But the problem is, this is expensive. You also do not want this because, since laying a pipe, water is expensive, right? Let me minimize the amount of pipe being laid underneath water. So this is the least possible value, right? A direct pipe channel towards land. But the problem is, you'll be laying a lot. Let me use another color. You'll be laying a really long distance for land, and that's not cost efficient either, because laying pipe on land costs money as well. So what is the perfect combination for you, such that the grand total amount spent is the least? To do that, you will have to come up with the cost function. How much it costs in general, that means using a variable, how much it costs to lay both the underwater pipe and the land pipes. So let's go ahead and come up with our very own equation. So there are two variables here. Well, when it comes to the cost function, the cost would just be the amount of water pipe, 60,000, times the length, right? Plus 45,000 times the length of land, right? Length of water. So if only we can make this a variable, right? Length of water, and make this a variable, right? Length of land. Let's go ahead and do that. Up to you. You can choose the length of land to be a variable. For example, this will be x. All you need to do is make this in terms of x, which is in fact not too difficult, because if this is x, this would be 12 minus x. So length of underwater pipe would be just square root of 8 square plus 12 minus x whole thing squared, which will give you 64 plus 144 minus 24x plus x squared, which simplifies to just x squared minus 24x, 64 plus 144, 208. Then we are going to push this, because this is the length of water in terms of x, we're going to push this into here to give us a cost function of 60,000 x squared minus 24x plus 208 power half plus 45,000 x. Then we will differentiate this, because I want to minimize the cost with respect to x, right? So dc dx equal to 0. So to find dc dx, you first differentiate this. Power bring down 30,000 x squared minus 24x plus 208 power negative half, and then don't forget to do chain rule and multiply by the differentiation of the inside, which is just 2x minus 24. This will simply give me, differentiating this will simply give me 45,000. Equate this to 0, you will get 30,000 2x minus 24 over, because this is power negative half, right? So the square root lives below. X squared minus 24x plus 208 whole thing square root equals to negative 45,000. Clean this up, divide both by 1,000, both sides by 1,000. This will be gone. 30 and 45 simplifies to just 3 and 2, right? Okay, so this question becomes 2x minus 24 equals 3 x squared minus 24x plus 208 to the power of half. Okay, at this point in time, you can either continue solving by hand, which will give you an exact number, meaning you square both sides, and this one becomes a quadratic equation, right? And then you move things around, solve that quadratic equation, get that particular x answer. Or you can come back here and see the question whether they say they want any exact values. The question says if the cost is blah blah blah, how far should point P lie from point A to minimize the cost, right? So they didn't say, oh, you have to give it an exact answer, right? So what do? We use our GC. Using GC, we solve for the answer. And to do that, just plot this graph onto y1 and plot this graph onto y2. Oops, sorry, I left out a negative here because this is negative 3, my bad. So let me just key this into a GC. So after keying these equations on the GC on two separate lines, check out the graph, it looks something like that. By the way, you have to press zoom fit because the values are outside the default zoom range. So you have to zoom it. By pressing zoom fit, the calculator will automatically choose a good window for you, so you don't have to manually search for the graph by zooming in and out, so it's convenient. So now just calculate the intersection between first graph, second graph, and the answer will be 2.9289. 2.9289, and all you have to do now is come back to the question. The question asks how far should P lie from point A to minimize the cost. How far from here to here? So the answer is just 12 minus your x value that you have calculated. 12 minus 2.9289 will give me 12 minus 2.9289 9289 will give me 9.073 SM. Of course, you can choose either to use GC or solve by hand. If you think pressing GC is a bit slow, then do go ahead and just solve this pair of quadratic equations. If you don't like solving quadratic equation, and if you are given a choice, meaning question didn't say they want exact values, go ahead and use the GC. So that's it for these two questions. See you in the next video.